Okay, hello again. Thank you for joining us. Today we have a very exciting presentation. Our presenter is Sam Ennis. He's one of our client technical solutions specialists, demonstrating how to incorporate weather data into any retail sales forecast models using, of course, our own Watson data platform. Just as a reminder, this webinar is being recorded and we'll make it available afterwards. You will get an email with a link to the recording. And you can also ask questions via manage that and let Sam know when someone has any questions. So Sam, go ahead and get started.
Great. Thank you very much, Anna. I appreciate the introduction. Welcome, everyone, and thanks for tuning in to the webinar today. As Anna mentioned, my name is Sam Ennis, and I'm a client technology specialist on the IBM Cloud Analytics team. So I work with a range of clients, many of them in the retail and distribution industry themselves, on achieving success when it comes to leveraging data and analytics within their organization. So some of you tuning in today may have seen the title of the webinar and are tuning in because you yourself are in retail, or you may be a company in a different industry, or excuse me, you could be a company in a different industry as well, looking to effectively leverage data and analytics for your organization. So regardless of your industry, what I cover today will be valuable and I hope resonates with you. So I'd like to show you how we at IBM can partner with you and help enable you to leverage data effectively to answer the most important questions for your organization. So a little bit about me before we get started. That's me down in the bottom left corner. I come from a software development background before my current role here, evangelizing and selling our cloud analytics solutions here at IBM. And I'm coming at you live today from the San Francisco Bay Area. So my goal today is to share our IBM point of view on the value of data and how leveraging it effectively is essential to making your organization strong and competitive, and how we can enable the various roles throughout your organization that touch data on a day-to-day basis. The lines of business, IT, engineering, all of these roles, enabling them to collaborate on a common platform, the Watson Data Platform, which is our unified analytics platform on the IBM Cloud. So all in all, with the aim of making data simple and accessible for your organization. So I'll show you what the platform looks like in action with a demo, applying it to an example business use case. So we're going to forecast retail sales using weather data. And I'm looking forward to showing you the exciting things IBM is doing in this space to enable your organization to effectively manage and gain insight from data. So ultimately, moving forward after the webinar today, we look forward to continuing the conversation, hopefully, to start identifying areas of opportunities with you in your business where we can really focus to drive value for you and help make an impact. So I'm going to throw a hypothetical scenario right from the start here. Let's say a hurricane is coming, just to start things off on an optimistic note here. Think about a retail brick and mortar store on the coast that knew severe weather was approaching. What types of products would they want to stock more of? What types of products would be in high demand here? So I've got a couple of ideas myself based on my intuition. I'm guessing, flashlights might sell well here. People don't want to be stumbling around in the dark if the power goes out. I would also guess bottled water might be a good item to stock up on before a hurricane too, if I was a retailer. Well, the reason I proposed this scenario is in 2004, when Hurricane Francis was approaching Florida, Walmart asked themselves the same question. But they wanted to look beyond the obvious to discover buying patterns due to hurricanes in general, that were not intuitive and stock up appropriately. So they looked at previous similar weather situations in the past and a huge volume of sales records, and they applied predictive analytics to all of this data. So what did they find? Well, they saw in the past that just before a hurricane hit, strawberry Pop-Tarts sold at 7 times the normal rate, and the overall top-selling item was beer. So these results are not only, in my opinion, hilarious, but they're also remarkable. So this is a clear example of digital disruption, an organization leveraging data and analytics to create previously unknown insights. Companies across all industries are realizing that it's a must-have, or they need to do this to use data to better understand the customer, maybe to sense shifts in the market, and to innovate faster than their competition. So today I'm going to be showing how the Watson Data Platform can help a fictional retail establishment called Convenience Store USA quickly gain insight from their data in a scenario inspired by the Strawberry Pop-Tart story. We'll take a look at that specific use case of sales forecasting with weather data to show Watson Data Platform in action. But really, there are a variety of questions that a business like Convenience Store USA might be interested in finding valuable answers to with their data. And those answers might lie in data that they have currently, internal to the organization, maybe sales or CRM data, but it also could be data external to the organization, things like social media data, weather data, or data from IoT devices. So some of these questions that they might be asking are, how can we attract new customers? How can we better understand the customers that we currently have? And how can we cut costs or make our processes more efficient? So these are all questions that they should be asking and need to be asking to remain competitive. So let's focus in on a particular use case of sales and on this particular use case of sales and weather. So our Convenience Store USA organization has over 1,900 locations all across the US, which means shoppers experience a wide variety of weather conditions throughout the year. So I don't know about you, but I really plan my life based on what's going on outside. So in this sense, weather dramatically can affect things like my mood and my buying decisions and what I might pick up from Convenience Store USA. So at the moment, Convenience Store USA might intuitively predict that customers will buy more fountain drinks on hot, sunny days. Now, that'd be a pretty good assumption. What if we had an idea of exactly how much more they would buy, though? And what other products, maybe the chips, bags of chips or hot dogs, might consumers buy more or less of based on weather factors like rain, snow, or wind? What if you could predict, these less obvious connections and find some more those Strawberry Pop-Tarts insights? So the message for business value here is clear. Planning your inventory more effectively will allow you to profit. So weather data or other types of data, internal or external to the organization, may have some insights that Convenience Store USA was previously unaware of. And it's one thing to have the data, it's another to gain insights and operationalize it. So what might this look like in action, operationalizing these insights? So here is an example. So this would be a dashboard that someone in the business would be able to look at, maybe someone who's planning the inventory for the next week. Excuse me a moment while it loads up here. So what we have here is different gauges representing weekly revenue projections for 7 different product categories that Convenience Store USA sells based on a projected weather forecast for the week. So let's say I knew this upcoming week was going to be really hot and not have much rain at all. So these revenue projections adjust based on the weather forecast for the week. And they could absolutely help me plan my inventory more appropriately to realize profit. So I used the IBM Watson Data Platform to bring in my data, analyze it, and operationalize my insights, in this case in the form of this dashboard. I'm going to show you how I did it in a bit in my demo. So the point is, with more data from more sources than ever before, there's really the potential here to be better informed and to make business processes and decision-making smarter. The more data that you put to work, the better the business outcome. But there's a big but here. It's not all unicorns and rainbows and Strawberry Pop-Tarts. It's, as we've heard from many organizations, there can be challenges associated with using data effectively. So what really has been holding an organization like Convenience Store USA back from doing this? Often an organization's existing IT architecture, some of the skills, data skills, analytical resources they have access to, or culture can be inhibitors from capitalizing on these opportunities. So I'd like to say that these inhibitors fall into 3 different categories. The first one is collaboration. Oftentimes we have those who are touching the data within the organization working in silos. Maybe I have a spreadsheet or a report that I conjured up that's stored on my local machine, and I need to email this report around. It might get lost in an inbox or the file system. Different people in the organization are using different sets of tools for their analysis, business, IT, engineering, different sets of tools. And I really don't have one central location where I can collaborate around common data. And this really hinders my productivity here. The second is data access. Not only are the people working in silos, but the data is oftentimes stored in silos as well. So it's not just stored in one area. I have some relational databases, some in data warehouse, maybe some in Hadoop. It's hard to access data across these silos even before incorporating external or third-party data sources into my environment. So I need to be able to access the data regardless of location. And maybe I need to improve the data quality too to make sure that those sources are trusted and governed. And also, maybe sometimes marketing or business are dependent on IT to get that data for them. That can be a familiar story as well, which can really slow down the data analysis process if those tools are a little bit too technical to use to deliver that data. And last, when it comes to tools, it can be hard to know where to start. So different types of data professionals can find it hard to get access to the right tools appropriate for their roles. So maybe some users would like to innovate using new open source technologies, but don't really have the environment set up to do that. It can be really hard to focus on the data when managing and maintaining many different pieces of hardware and infrastructure, installing the software, making sure this hardware software is secure and can scale. Users really need flexibility here. So to not worry about the underlying complex infrastructure, but just gaining value from the data. So what can IBM Watson Data Platform do to help? So we created the Watson Data Platform to address these key inhibitors that we saw organizations struggling with. We realized data analysis is a team sport. There's many different roles throughout the organization that need to be able to collaborate around common data and workflows. So we created a platform that consists of these composable data services available on the IBM Bluemix Cloud platform. And you think of these services almost like Legos that we can help you fit together to create that best solution for you that's really going to drive the most business value for you. And Watson is in the name because we've infused these services with many of the cognitive capabilities of Watson. And you can also use Bluemix to incorporate application development here as well, and use APIs such as the Watson APIs, like natural language processing or sentiment analysis. Some of these cognitive Watson capabilities, you can incorporate those in with your applications and make them very data-driven as well. So all of these services are enterprise ready and benefit from our vast experience working with businesses. So we've created patterns that we know are going to be successful from a deployment standpoint. And cloud lets us manage that complexity for you when it comes to managing and maintaining the infrastructure. So we'll take care of things like high availability, security, scalability, and we can spin up these environments very quickly for you in the cloud and really focus on getting, you can focus on getting value from your data as soon as possible. So we saw there were some key elements here that we needed to incorporate and organizations needed to have a successful data environment. So the first is hybrid data management. That means, there's some data, workflows, or apps that maybe you're not ready or don't want to move to cloud, and that's okay. IBM really differentiates here when it comes to hybrid cloud environments, where it means, is your hybrid in the data sense? Is it structured, unstructured data, as well as hybrid in the cloud or on-premises sense? So wherever it resides, whatever type of data it is, you're all set. The second is data analytics and visualizations. So organizations oftentimes struggle with just a few people being empowered to perform analytics in a self-service fashion. So I should be able to gain insights myself without being dependent on just a few power users. And so things like cognitive capabilities to help the citizen analyst here. So things like being able to ask a question in natural language about my data, or have some cognitive automated starting points generated for me to help me create those visualizations, can really speed up time to insight, so we can democratize that data analytics and visualization capability. Unified governance. So is the data any good? Is it relevant? Is it compliant? This is built into the platform as well. And then open source. So we at IBM are huge supporters of open source. We realize that companies need to use tools like Apache Spark and Hadoop in order to move quickly and innovate. So we also don't want you to feel like you're getting locked into a proprietary platform. So we differentiate with open APIs and a partner ecosystem and connectors to help you to integrate with existing on-premises data stores or other clouds you may be leveraging as well. So, and lastly, I'll mention data science and machine learning. So this is the capability to incorporate deep analytics, predictive analytics, and embed machine learning in your applications to really operationalize your analytics. So maybe you're looking to segment your customers more effectively, predict likelihood of churn, likelihood of promotion response, all sorts of questions here too, and these are important as well. And we have a range of offerings here depending on the characteristics and preferences of the particular analyst doing that machine learning. So all in all, we want the users throughout the organization to be able to collaborate, to use data and ingrain it into your applications. So supporting decision-making, supporting business processes in a really very simple and easy-to-use fashion, answering valuable questions for the organization. So let me show you what this looks like in action with a demo. So here's an overview of the process I'll be demonstrating today using Watson Data Platform to create weather-based sales forecasts for Convenience Store USA. We'll start by looking at 3 years of historical weekly revenue for a particular Convenience Store USA located in Des Moines, Iowa, divided into the main product categories within the store. And so we'll upload that data to our Load and Go data mart in Watson Data Platform. We'll also look at Des Moines' weather data from the past 3 years as well. And I'll mention this weather data is an example of data that you could obtain through the Weather Company API on IBM Bluemix. It has some uniquely precise weather data that we've added to our platform for you to be able to use since we acquired the Weather Company in 2016. So this data was brought in and stored in a semi-structured JSON data store, but I'll show you what we can do to easily keep it in sync with our relational data mart through what's known as a schema discovery process. So there's a lot of flexibility here around data formats that you can analyze on the platform. So we'll take our data and use our self-service data preparation tool to prepare and move this data into our data discovery environment where I can do some quick and easy data discovery. And I'll ask some questions in natural language and visualize my data. So the great thing here about this prep and discovery stage is I can do this very easily as a citizen analyst without dependence on IT to deliver me the data or the insights I need. All in this common platform. So we'll then pass our analysis to the data science team to explore the data with predictive analytics and machine learning using Python and Apache Spark. Then we can deploy our models to use them for predictive insights and business decisions in the form of an application dashboard. So Watson Data Platform really enables all of these steps in this workflow and the roles throughout the organization to integrate very well and collaborate from start to finish. So let's get started here. We'll start by looking at my sales data set. So these are weekly sales numbers for 5 different product categories at the Des Moines location. So this is data that maybe I'm a manager at Convenience Store USA and I've aggregated this personally on my desktop, but I haven't really done any meaningful analysis on it yet or shared it with anyone. Now, Watson Data Platform is going to let me do that very quickly. We call it load and go. So I'm going to load this data into my data mart within Watson Data Platform, which is DB2 Warehouse on cloud. So here I have DB2 Warehouse on cloud, and I'm able to load in this file. You know, data warehousing is all about bringing many types of data in your organization together for reporting and analytics purposes. And this could support decision-making from an enterprise-wide level. It might support a particular line of business. Here you'll see me creating a new table here known as weekly sales. Just uploading this in here. And you know, DB2 on cloud, or DB2 Warehouse on cloud, excuse me, is all ready to go for you, tuned for analytics, ready to scale when I need it. And it's fully managed by IBM and optimized for analytics workloads. So I've got some things going on beneath here, like in-memory DB2 Blue acceleration. And we've also incorporated some Netezza in-database analytics from the powerful data warehouse appliance line that we have. So I can really get some great analytics performance here. And with that, management by IBM, things like high availability here too, that's available out of the box here as well. So I'll mention too that I'm loading from my desktop right now, but certainly many clients would load data in a more traditional ETL fashion with a database connection. That'd be easy to do as well. So this is great. I've got my sales data in here ready to go in the data mart very quickly. But what is the fun of having a data mart with just one type of data in it? I want to include my weather data as well. So here I have the weather data pulled up. And as I said, this is an example of data you might pull in from the Weather Company API on IBM Bluemix. And I initially have it stored in a JSON format, which means it's semi-structured data. It's not your traditional rows and columns of a relational data store. So I pulled this data into Cloudant, which is our fully managed NoSQL database on Watson Data Platform. And it's worth mentioning Cloudant is massively scalable, and it's great to support things like web or mobile applications with very low latency access for many concurrent users. So it's also easy to develop with, with your applications through just a REST API. So I'm going to show you how I can sync up my JSON weather data with my SQL data mart. And I could use a similar functionality here for use cases if I wanted to incorporate semi-structured mobile app, web app data, or IoT data that I was using in cloud or pushing into Cloudant. I wanted to analyze that as well. So it's really very, very easy to do. I just create a warehouse here. I connect it to my DB2 warehouse on cloud, and the schema discovery process here keeps it in sync. So if I added new JSON documents to my data store, they would update in my data mart as well. So this is a very powerful tool for analysis. So this is great. I've got my 2 data sets and a couple of tables ready to go. And right now it would be certainly possible to use SQL to query this data. But fortunately for users who want to do some more ad hoc analysis but may not be proficient in SQL, they can use a service called Data Connect to connect to many different data sources, such as, excuse me, did I hear a question?
Sam, it's Anna. One of our attendees is asking if you can speak a little slower.
Oh, absolutely. Sorry about that. I'll slow it down. I have a tendency to talk quickly sometimes, so I'll definitely slow it down. Thanks for letting me know. So, I've got my 2 data sets here in DB2 ready to go, and I could use SQL to query it, but I'd also want to enable some citizen analysts throughout my organization to connect to these data sources and prepare it for analysis themselves. And so here I have Data Connect open, and I can see the different connectors that I can connect to many types of data stores, whether those are on premises in your organization currently, or if those are in the cloud as well. So in this case, I'm connecting to my DB2 warehouse on cloud. So within Data Connect here, I can select myself this DB2 warehouse on cloud and the particular tables within the database that I want to include in my data preparation. I'm going to select my weather data. I'm going to select my weekly sales data as well. And then here what I'm doing is refining and copying this data. We call this an activity. So this is a sequence of operations that I'd like to perform and be able to execute at this point. And if I'd also want to schedule this in the future, to load data from particular source systems, and you saw those connections that maybe those source systems might be, and load it into a destination system. And so in this case, I'm going to deliver it to a data discovery tool called Watson Analytics as my destination, but I could certainly load it back to a data warehouse, to a different database, depending on what works the best for my architecture and my organization. And so here's an example of some of the self-service data preparation I can do here. there's a couple of columns in this particular table here that I don't really need for my analysis. This is just metadata that Cloudant tacked on to this data, and I know it's not going to be quite relevant for this particular use case. So I can remove these columns. And I can also do some standardization of the different data types here too. So I know this date is in a slightly different format, so I want to convert that to be a standard date format here. And so now that matches the date that's also in my weekly sales data. And again, I'm able to do some more transformations. I can join these two data sets together because I think, all in all, what I want to do is be able to analyze it all in one table and be able to gain my insights there. So if I select the date, I know that that's common between the two data sets. The date is it's on a weekly basis. I can then join these sets together. And I'll mention here too, when I run this job under the hood, Apache Spark is powering it. So we really embrace open source, and Apache Spark is one example of an open source technology that we've really embraced. It's a powerful computing framework that lets you do things like data preparation, and you'll see later things like machine learning on massive amounts of data. So we've infused Apache Spark throughout the platform here as well. So here I've selected my source systems. I've done some transformations as well. Now I want to select where I want to deliver the data to. And in this case, I want to deliver it to my data discovery tool, and that's known as Watson Analytics. And I want to store it in this particular folder here too. I'm going to give it a descriptive name of sales weather. And then I can also name this activity, this flow from source to destination systems with the transformations, so I can repeat and schedule this in the future. And so in this case, I'm going to call it DB2 to Watson Analytics, taking a couple of tables from DB2 and preparing them and delivering them to Watson Analytics. So at this point, things are looking good. I'm going to click Run, and this will start this activity now to extract the data and deliver the data. And I'll mention too, those transformations aren't affecting that source data. So it's not like we're going into that database and deleting those columns or anything there too. It's only extracting the data, and then Data Connect itself does these transformations and delivers that to its destination as well. And so you can see it's running right now, this data delivery. And within here too, I'll show you that schedule. So I could say particular days out of the month when I wanted this same data delivery to happen. Maybe I know that my source data is updating on a daily basis or a weekly basis, and I want this job to be scheduled to update and get my data ready for my analysts to analyze at particular times. So that is what I could do there, but in this case, I'm just gonna run it this once. So it looks like we're waiting right now for it to copy over to Watson Analytics. And while we do that, though, I'll jump into Watson Analytics here and speak for a moment about what Watson Analytics is. So this is our data discovery tool that can really enable a citizen analyst to dive into data right away and create some insights very quickly. And so there's a couple of things that Watson Analytics has that enables me to do this. And here we're on the data page here. So these are the different types of data sets that I have available for analysis. I can load in Twitter data. I can load in different types of files or database connections. In this case, this data delivery of Data Connect, it is incorporating here as a new data set. So for the sake of time here, actually this should be done in just a couple seconds. So I'll showcase, the first capability here is the ability to ask a question about my data in natural language. And so I'm going to select this data that I had just delivered here into Watson Analytics, and I can ask it a question, and just like I would ask a friend about my data. What are the sales of products by month? That's what I want to look at first. And Watson Analytics will interpret what I asked and generate some visualizations, some starting points, so I can really get my hands on this data very, very quickly. And here's kind of the most relevant guesses that it has for the visualization that I want to view. And so this first one looks great. It nailed it. I want to see a trend of weekly sales over month by product category. So I'll select that here. And very quickly, I can see this visualization. Just want to make a couple of tweaks to this graph here too, and Watson Analytics makes that very easy. I'm going to aggregate on the average sales as opposed to the sum of sales. And I also want to change the x-axis just to month. So an average across all years, what the sales looks like for each month. And so this is great. I've got my different product categories here. Got beer and alcohol, chips and snacks, coffee and tea, and I see their performance on average every week by month. So I take a look at fountain drinks, and I can see that those sales are going up in the summer, and that's fairly intuitive. It looks like more people would, or it seems intuitive that more people would buy fountain drinks in the summer. And I can also see coffee and tea. It looks like the sales of that goes down slightly in the summer. People aren't needing that tea or coffee to warm up in the summer nearly as much as they do in the winter. So see some interesting trends there based on the time of the year. And so there's other questions that I've actually prepared. I asked these questions before just to save a little bit of time here, but certainly the same interface there of asking Watson Analytics would help you to generate these visualizations. And this one is what drives weekly sales, and it's ability to do some pretty advanced analytics here, some diagnostic analytics to see what are the particular drivers or what are the things that are affecting that weekly sales number. And Watson Analytics gives me this capability just by asking this question. And I can see here that some of the biggest drivers of weekly sales are some of these weather features. I see temperature is affecting things, and snow and rain with quite a bit of strength here is affecting those weekly sales numbers. So that really prompts me to do some more analysis here on how exactly snow or temperature is affecting these product categories. And here is a predictive model that Watson Analytics helped me create to predict that as well. And so you see here on this decision tree, which is a type of predictive model, it shows me based on the product that I've selected, the different branches here based on different amounts of rain, on snow, on temperature, how many sales I can expect. So it looks like the highest sales that I can expect here are an average weekly sales of over $6,500, and the temperature, look at the decision rules here, that when the product category is fountain drinks and the average temperature is greater than 48, that's when I can expect my greatest sales. And so that's very interesting how I was able to create this predictive model very easily, just by asking the question. I've also generated some visualizations around the sales and the temperature, and I see fountain drink sales going up in the summer. I also see coffee and tea going, up with higher temperatures. I see coffee and tea going down with higher temperatures as well. And chips and snacks, doesn't look like the temperature is really affecting it very much here. So these were some interesting visualizations. And I took a look at snow, and I saw, oh wow, that is a huge amount of sales here when this snow is 9 to 11 inches. So a lot of snow apparently means a lot of sales of toiletries. And I've kind of heard people tend to stock up on things like paper towels or toilet paper before a big snowstorm hits. So that's kind of my intuitive reaction to seeing this data, is maybe people are stocking up on those things before snowstorms, but we're certainly seeing a lot of sales of toiletries when there's a lot of snow on the ground. And so I've created these visualizations myself, and now I want to share them. So what I can do is take all of these visualizations and put them into a dashboard. And I can share this with my data science team. And so I can send them a link or drop in an email with a link to this dashboard, and they can take a look here and say, hey, those are some interesting starting points for this data analysis. Let me see if I can create a predictive model here, do some deeper analytics, and really operationalize these insights for the business, so we can do some sales forecasting based on the different weather conditions. So I pass it over to the data science team. I did this analysis here in Watson Analytics. Myself, as a citizen analyst, I'm passing over this to my data science team. And as a data scientist on Watson Data Platform, I would be using Data Science Experience. So this is a tool that has really everything a data scientist needs. And we talked to many data scientists when you're creating this offering to ask them, what is important to you when it comes to effectively analyzing data? And they said the ability to collaborate around common projects is important. So we have this ability for you to create a project and then share it with other people, and you can collaborate together there too. Sometimes it was hard for data scientists to collaborate. They also mentioned that things like example data sets or tutorial notebooks and the ability to learn more about some of these new open source technologies that are coming out was very important as well. And so we built that into Data Science Experience. And then lastly, they said we need something that's performant. So we need something that under the hood is going to provide a lot of power for us to analyze large sets of data. And so Data Science Experience is built on top of that Apache Spark cluster that I was talking about. I mentioned earlier that's infused throughout the platform. It's really a framework that enables you to analyze very large sets of data. And underneath here on Data Science Experience, you have that fully managed Spark cluster up and running, ready for you to go and ready for you to use without any installation or configuration of hardware and software on your part. So what we've done so far is, yes.
I'm sorry.
Another question?
I had missed one question about the model outcome when you were presenting it. The question is if you know how the strength of that model is computed.
How the strength of, excuse me, let me pull that model up here. Asking about these strength numbers over here, how that's computed. So I believe it's a decision tree algorithm here based on things like splitting where there's the most entropy. So kind of the standard decision tree algorithms for predictive modeling. Though I'm not entirely sure which decision tree algorithm it's using, but there's one that is being used for both this driver analysis as well as the predictive model. But if that's information that whoever is asking that would like to know more about, please feel free to reach out and I can get that information for them.
Thank you.
Yeah, absolutely. And so, yep, so we're back to the data science environment here. As a data scientist, what I would do is take this data and create a notebook. And a notebook is an environment where there's both code and documentation all in one place. So I, as a data scientist, can perform my analysis, but also document that in a way where it's easy for those who maybe aren't quite as familiar with code to understand as well. And as I said, it's on an Apache Spark cluster, so that enables me to use Python code or R or Scala really to do some robust machine learning, transformations, things like graph analysis. It's really provides a very simple way to do these types of rigorous analysis on large data sets. It has certainly some robust capability here. And so right now we're going to be using it for a machine learning model to forecast the impact of weather sales, but you might want to use it for things like customer segmentation, recommendation engines, all sorts of predictive models that you could create in this environment. And so within this environment too, data science experience, this is based on an open source Jupyter notebook, if anybody has experimented with that in the past. But we've really enhanced it with some capabilities around being able to add comments. We've loaded in many of the environments or data analysis libraries that you might need as a Python or R coder in order to do your data analysis very quickly. And you can also insert connections from different places very easily with automated generated code. So this code cell was all automatically generated for me just to get that data in to my environment. And so, if you're sitting here thinking, hey, I don't have a coding data scientist in my organization, I'm not really sure if this would be the right fit. No, that's totally fine. We have other options on the platform that provide more of a drag and drop or modeling wizard option for creating predictive models without code too. For the sake of time today, I'm demonstrating what the coding environment looks like, but certainly can provide some more information to you on other options you have that don't necessarily involve the code. And so, it's not, as I said, it's not necessarily that you understand exactly what this code is doing here, but basically I'm preparing the data for analysis. And here I have my table of weekly sales for chips and snacks. I decided I want to just focus in on one particular product category here, not necessarily do all of them, but just for the sake of simplicity here in the demo here, just do one of these product categories. And so I created just doing some more descriptive analysis here on this data set, trying to figure out any other correlations that we may have missed in Watson Analytics. I see something very interesting here. We looked at temperature and snow in Watson Analytics, but we did not take a look at the wind feature, how the wind affects the sales of the different product categories. And I see a huge negative correlation here with chips and snacks revenue. So that means people on a very, very windy day are not buying nearly as many chips and snacks, which I find a funny fact. And I'm wondering, a funny feature to see in my data set. And I also see that the hot and fresh revenue is going up with higher wind. So in my mind, I'm thinking, are people afraid their chips and snacks bags are going to blow in the wind, and they end up hunkering down with like a big hamburger or something from the hot food section that won't necessarily blow away? That's certainly assigning an answer to something that we might not quite know why it's happening, but it's definitely something that we would want to look into more here. And so here I'm building a machine learning pipeline with Spark. So with a few lines of code, I'm able to feed this data into a model. In this case, we're using linear regression. So, creating based on particular coefficients and an intercept, kind of like a line equation. What can I expect for my revenue prediction based on the different inputs that I'm putting into my model? And so I train and test this model in a typical fashion that oftentimes is used in predictive analysis. And here I can see the results of my model. So each dot here shows, or the axes here are the revenue that I projected for my chips and snacks revenue. And then this is what the actual data was. So I took some parts of my data and didn't run it through the model, and I used it as a testing data set. So I was able to see, what the actual revenue that was already labeled on that data set was based on compared to what I predicted it was. And I also have a couple of evaluation metrics here from my Spark machine learning linear regression model. And looking at these evaluation metrics, it's not the best model here. In an actual environment or an actual use case, if you're doing this, you probably want to tune this model a little bit. Maybe split the data set up using some things like k-folds evaluation, if that means something to someone. Just different ways to tune the model to make sure that we can really optimize that. So we can operationalize this predictive model too as well. So Watson Data Platform lets me deploy that to a REST endpoint, and then I can use that for scoring. And so here I have my dashboard that I showed at the beginning that can then use this in an operational fashion. So I used, really quick, to create this dashboard, I used RStudio, which is built into IBM Data Science Experience, but I could make my own custom application as well in order to use these endpoints and use these models that I deploy. And again, I didn't show quite the deployment process here, just for the sake of brevity or for sake of time. But I'd be happy to answer questions about what that looks like as well for how we would operationalize this model that we created and put that, get it ready for scoring. Options there around: is it a streaming use case? Is it a batch? Is it different types of scoring options there too. And so here again, we see the dashboard that we had at the beginning, and it's all ready for the business to use. And I can predict my weather forecast. Maybe it's going to be really snowy and really windy. And I can see, with this wind speed increasing, people are not buying those chips and snacks. Definitely something that we saw in the data set. So we saw here how we could take our sales and weather data and load it in to Watson Data Platform into the Load and Go data mart, do some preparation for analysis, discover some insights very quickly using our data discovery tool, and then develop and operationalize analytics models with our dashboard. And this was all within a collaborative environment between the different data professionals within your organization. So I'll add a few names of offerings. Names of offerings I talked about today too for your reference if you have any questions on a particular one. I did keep today fairly high level with the overview. I may have talked a little bit fast too. Please feel free to ask any questions about things you may have missed, or maybe I went through fairly quickly. And I just covered one of many possible use cases that you could use Watson Data Platform for. But if you have specific questions on portions of this flow or other additional services we might have on Watson Data Platform, I'm certainly happy to field those, either through the chat during the webinar, or I'll put my email out on the next slide and you can reach out directly. So we can have a conversation here too with what business use cases with data and analytics would be the highest impact for you to explore right now. And I'll mention too, there are free 30-day trials of all the products I went over today if you'd just like to get your hands on and use them yourself too. So with that, Watson Data Platform will really allow you to put your data to work in a simple fashion, in a collaborative environment, creating value and overall a competitive advantage for your organization. So I encourage you, right now I'm open to any questions that are from the chat, as well as feel free to reach out to that email there too. So Anna, do we have any questions on the chat?
We don't have any questions, Sam, but I'm wondering, because we still have some time, I'm wondering if it's easy for you to show how they could get started. Because, there's free options and all this, but where do they go and how do they do it?
Yeah, absolutely. That's a great idea. So I will go to my web browser. That's going to be step one. And the trials here, so most of these services are available through IBM Bluemix. And so you're going to want to go, let's see, go from step one. So search Bluemix. Just going to start from step one here, searching Bluemix on Google. And then I'm going to want to look at the catalog. So actually any of these links will probably get you up and running. So I want to go to the IBM Bluemix, and then I can do Get Started Now, or Get Started Free. And this will guide me into signing up for a free 30-day trial of Bluemix, where you can really use any of the services here within the catalog. I think it's opening me up to Bluemix right here. But I'll show here too. So once you have signed up for that free 30-day trial on Bluemix, here's a catalog of available services that you're able to try out and to use. And switch back. Okay. And we've got services here from the infrastructure side of things. If you're looking for, a virtual machine to do more of the infrastructure as a service, we've got a lot of options there around application development here too, with some boilerplates. What I focus on here today, though, you'll click on Data and Analytics, and you can see the different data offerings that we have available. And for example, Cloudant, if I wanted a NoSQL database here, I can simply click on that, and it will ask me if I want to create this. And most of these services have a free version here too, so I can spin up the light plan, the free plan of Cloudant, and get ready with that very quickly. So this is going to be how you'll get started with, I think, all the offerings I showed today. Yep, data science experience here too, Data Connect. And the only other thing I would say is that Watson Analytics is slightly different process to get started with the trial there too. So if I search Watson Analytics in Google, this trial is a separate trial. So I can click Try for Free on Watson Analytics if you liked what you saw today there and want to use that for data discovery. So anything I may have missed there, Anna? Is that kind of what you were thinking for encouraging people to sign up for the trial?
That I would add or ask you. So most of the services that you use during your presentation are here on Bluemix. Outside of it, if you want to focus on visualization, then people would need to go into Watson Analytics, which is not through the services. And then for data scientists, go to Data Science Experience, which is also separate from Bluemix, correct?
So actually, Data Science Experience was recently added to Bluemix. So you can actually just click on that through the catalog here. It used to be a separate thing, but it got integrated into the platform. So you can just spin it up and create the free version here from Bluemix.
Awesome. That's what I wanted to clarify for the people in the audience.
Yeah, thanks. And I'll also mention here too, a lot of services that I didn't cover today too, especially around open source offerings. We have a lot of different types of databases. Maybe you've heard of MongoDB or Postgres, different fully managed offerings of those services as well. So if your company is more is exploring open source, or you currently use open source, we've got fully managed offerings there that can help you get up and running very quickly. And so yeah, I hope I gave a good explanation of signing up there.
So I don't think we have any more questions, Sam.
All right. Well, thank you again to everyone, and thanks, Anna, for coordinating and hosting this. I hope I've opened up everyone's mind, a realm of possibilities here of what Watson Data Platform can help your organization achieve, and you're excited about some of the ways that we can help drive value here with your use of data and analytics. So, thanks again for tuning in, and we certainly hope to speak to you soon.
Thank you so much. Thank you, Sam, and thank you everyone for joining us today.